Hi, organic chemistry class. Sorry that I'm having to do this online. I wish I could do this all in person. I was trying to think over about the past 24, 48 hours, what all I wanted to cover with you in our class today. And I've kind of settled on going ahead in the book a little bit and teaching you something through this that is basically just rote memorization. It's something I try not to do a whole lot. I don't like rote memorization, but I thought it would probably be easier to communicate that this way than trying to put together a much more elaborate video while I'm down here in the swamp. So anyway, what I'm going to do is I'm going to switch over and you're going to stop seeing my face. I'm switching over to a chemical drawing program that I use. It is called ChemDraw. And what I'm going to show you is our very basics of nomenclature. So back when you were in general chemistry, you learned about some nomenclature as it pertains to inorganic molecules. You learned if you have things like potassium and chloride, and you would have potassium chloride. If you had phosphorus and chloride, you could have something like phosphorus trichloride, and it was based off, like the charges of things and oxidation states and such. Nomenclature in organic chemistry is very different in that. We basically name everything according to the number of carbons in the chain, and we have, molecules with many, many long chains. So you can learn names of organic chains up, there are systematic names for things with over 100 carbons in the chain. That would be just absurd for you guys to have to learn. I don't know that many. I don't know anybody that would know all those off the top of their head. But the ones that I have you learn are carbons 1 through 12. So what I want you to know is, let me see if I can do that again. Okay. If you have a 1 carbon molecule, you call it methane. Okay. I'm putting on the hydrogens here because it would be wrong to not put them on there, but I do want you to just kind of at this point think of methane as having 1 carbon. If you have 2 carbons in a chain, then those are called ethanes. You might know of some methane and ethane based molecules like methanol and ethanol. Those are alcohol versions of these molecules. The methanol has 1 carbon, ethanol has 2 carbons. So we use that kind of base parent name for everything, and you just have to memorize them, and that's why I was thinking this might be useful for us today. So if you have 3, then you end up with a gas that many of you have heard of called propane. It is used as a fuel source very often in the United States. Why can't I get this to... Just trying to make this spread out a little bit. If I hit tab, it yells at me. Okay. So methane, ethane, and propane. Those are 3 really common gases. All 3 of them exist in the gas phase standard. You can get propane in tanks, right? You can get propane for like your grills and stuff like that. Methane is actually a gas that is common in decomposition, and so you can actually get that and harvest that out of things like landfills, and some companies do that. If you have 4 carbons in a chain, there we go. That one is called butane, and you might be familiar with butane because that is also a fuel source and is used in a lot of cigarette lighters. And then after butane, they start to get a little bit more kind of obvious in their naming. So if you have 5 carbons in a ring, the prefix for that is penta. Penta means like pentagon, 5 carbon, or a 5 sided shape, right? So 5 carbons is pentane, like pentagon 5. I do get students who get confused between propane and pentane simply because they both begin with the letter P, I think. But it's important to remember that pentagon 5. If you can remember that, then it's pretty easy to separate the 2 in your mind. You will also notice that the carbons on the ends have, except with methane, the carbons on the ends have 3 hydrogens attached to them, and the ones in the middle have 2. We'll be talking about Lewis dot structures and stuff like that next week in class, but just in the meantime, I think you can probably look at these and kind of still memorize the basic number of carbons without really having that foundation of understanding structures. If you have 6 carbons, you get hexane. If you have 7, you get a molecule called heptane, Heptane. Okay, and then what I'm going to do is, let's see if I can, nope, okay. I want you to try and fill in octane, which is just the next one down, so 8 carbons. And I want you to look at how this kind of chain is going along. Octane, nonane, which is 9 carbons, decane, which is 10 carbons, decade is 10 years, decane is 10 carbons. So that prefix kind of makes sense again. And then 11 carbons is un decane, un meaning 1, uno, for example, decane meaning 10, so 1 and 10 is 11. Dodecane, and that's the extent of the ones that I make you guys learn. So I have you learn carbons 1 through 12, okay? Some of those are easier to learn than others, but, you know, I think that's a pretty reasonable number, and we can name a lot of molecules out there if we just have these 12 kind of under our belts. The next thing that I wanted to talk about, and obviously you can look these up and see if you get those right, but the next thing that I want to talk to you about is what are called functional groups. Okay, and I'm just going to start us off with a couple of these. And you can think of functional groups as areas where chemistry happens. Hydrocarbons in general are very unreactive. They don't do a whole heck of a lot of anything. They undergo combustion reactions, and there's one called a free radical halogenation that they do, but they're widely not very reactive at all. So they tend to be very, very stable how they are, and that's just because carbons and hydrogens form really strong bonds with each other. Okay. But we do have those other elements that we talked about on the periodic table, oxygen, nitrogen, phosphorus, you know, and those are going to lend certain types of reactivity to a hydrocarbon, and it does so in a very predictable way, okay, which is what's kind of neat about it. So the ones that I want you to kind of learn first are ones that you have hopefully seen in general chemistry. So back when you took general chemistry, one of the molecules you had to memorize was acetic acid. And if you remember, acetic acid had something on it that looked like this. Okay. Put on my lone pair. Okay. And if it was acetic acid, on the far left side there would be a CH3 attached to this. So right now I don't need you to think of this as being attached to anything specific. Just think of it as attached to like anything. So I'll just kind of put a random little anything bond over there. If you have something that looks like this, where there's a carbon bound to 2 different oxygens, like a carbon with a double bond to an oxygen with a single bond to an OH, like what you see here, that's called a carboxylic acid. Okay. We call those organic acids. And you can get a lot of them that look like that, okay? Lots and lots of molecules have that carboxylic acid functional group in them. Another one that I want to show you looks a little bit like a carboxylic acid, but it's missing that double bond to the oxygen. So if you have a carbon bound to an OH with just the OH, not the other carbon, but if you have something that looks like that, that is a functional group called an alcohol. Okay. And then the next one that I want you to learn is where you have nitrogens attached. And there are many functional groups with oxygens. There's many of them with nitrogens, but for the sake of what I'm showing you, I'm just going to give you some very basic examples of some different types. One thing that's probably going through some of your minds right now is, how do I know where to draw the bonds, and how does it matter this, if I do it this way and if I do it that way? I'll talk about that in class as we go. Let me put on my lone pair electrons. Okay, and so the answer is oftentimes it doesn't matter, but sometimes it does, and we'll talk about that in class. If you have something that looks like a carbon bound to a nitrogen like this, then those are called amines. Amines. And then lastly, if you have, if you have two carbons bound to each other with a double bond like this, then that is a molecule called an alkene. And if you have one with a triple bond, oh, that didn't work right, hold on. There we go. All right, so if you have one with a double bond between two carbons, it's called an alkene. And if you have one with a triple bond between two carbons, it's an alkyne. And if you have a carbon-carbon single bond, then that's called an alkane. So just think of these bonds that I have kind of drawn out to nowhere as meaning whatever. It doesn't really matter what they're bound to. An alkane is not really considered a functional group because it's basically just a hydrocarbon with nothing special. But we have alkanes, alkynes, alkenes, amines, carboxylic acids, and alcohols. Those are the first few that I think are good for us to cover to kind of get an idea of what things are called and how to name them and such. So let me make that a little bit bigger. So anyway, here are your notes for today, and I basically just need you to memorize these things for class sometime next week. I'll probably actually be talking more about the naming and such on Monday after this one, so the Monday after MLK Day. That's kind of the plan. So we're learning these about a week earlier than I normally do, but I think that's fine based off our circumstances. But go ahead and look through and do methane, ethane, learn all those. And then you can also figure out the structures there for octane, nonane, decane, undecane, and dodecane, as well as kind of being able to recognize those different functional groups if you see them. If you look at the hydrocarbons that I have on the top half of this page, all of those would be considered alkanes because they're all carbons singly bound to other carbons. And that might be hard to see right now because I have them in a condensed structural format. But you'll just have to trust me on it. All those are considered alkanes. And if you want to, you can do nomenclature for alkanes right there. If you have any questions on this, feel free to hit me up. I bought some more internet time. I get very little of it because I have to use satellite internet where I am right now. But I hope that this video kind of helps give you a little bit of something for you to work on in lieu of class today. I think, let me get back here. There we are. So I think that this is a fine enough lecture for Fridays. I think that it's not particularly long. All I would do is normally, take this and do it a few weeks later and do a lot more along with it, but it's fine for today. The one thing that I want you to look into for class on Wednesday of next week, which is the next time we meet, is to look into Lewis dot structures. Do a little bit of review and refresher on that. Maybe watch a Khan Academy video if you want, something like that. That'll help also prepare us for class on Wednesday. Because remember, MLK is on Monday, so we don't have class then. And then also, refresh yourselves on intermolecular forces. I'll talk about them as well, but I think it's always good to kind of come in remembering a bit of that review ahead of time. So intermolecular forces, or IMFs, things like dipole-dipole interactions, hydrogen bonding, and van der Waals interactions, or dispersion forces, or London dispersion forces. Those are basically all the same sort of thing. And it kind of depends on who you had for general chemistry as to what you might call them. So anyway, email me if you guys have any questions. I do still get email pretty well on my phone out here, which isn't a problem. And I will talk to you guys I'll see some of you on Tuesday for lab. Make sure you bring your lab notebooks. Make sure you bring clothing appropriate for lab. Make sure you have goggles and a pen. That's all I need you to have in class on Tuesday. Okay? So I'll see you then.